All right, so this is where we had stopped previously. So let's just take a look at this. Okay, so there you go. See, so we have like this little spike that is going through. Let's just see where it is coming from. Yeah, okay, so this is coming from here. Yeah, there we go. Okay, so let's see if this thing works now. So if I take this group and yeah, there you go. So we're selecting edges that are small enough, maybe slightly smaller. Yeah, and then we can try to do the dissolve. Yeah, so that's the general idea. So it doesn't really cause too many issues because the dissolve will fill up the faces that have been deleted. But what it does is that if you have issues like those, this will take care of it. So that's what I've been wanting to show you for a while, but I couldn't find any place where it was happening. Okay, so this is the armor that we had. So what I want to do in this particular chapter is I want to try and create the holes for the connectors and then maybe also do like booleans or like cuts on the edges. Okay, so let's try something, right? Like I'm going to turn off the VDB because this looks pretty decent as well. Like even with the subdivision surfaces, it looks pretty nice. Because as I said, like the main difference between like this is fairly sort of light. Okay, the problem or the mistake that I made with my original design was that, the pieces that I was dealing with were actually pretty high res. So it was much more difficult, to do booleans and stuff on top of it. Like it would constantly cause issues. Whereas this stuff is like, like if you look at this is pretty light. Like it's not very dense geometry wise. Okay, so the first thing is let's try to create like, booleans for this. So what I'm going to do is we want to create something on the top, right? So I'm going to duplicate this, or let's just create groups for this. Okay, so I'm just going to come in here and we'll create the group for the front. Let's just call it F. And then I'm going to just delete the rest of it. So we'll take a blast here and I'm going to delete non-selected. So I have the front. Then the second thing is we'll take a divide, or let's just do we'll do a poly extrude, and I am going to inset this. Again, we can't inset this, so I'm just going to scale it, and we'll turn off the sides. So let's just take transform and we will scale it down. So it's about, yeah, so it's about that much. It doesn't work perfectly because, the insetting becomes a problem. But what we also need to do is, because it sort of scales down, we need to do a race op and sort of bring it back up. So it attaches, it's back to the position where it's supposed to be. So we're just going to do a race op and like this, and we'll pick up the subdivide. Yeah. And we can just do minimum distance. Yeah, there you go. So now it's like, properly back over there. Okay, and then I want to take a divide. I want to get rid of everything in the middle. Let's just pull this down because this is going to be a little longer. Yeah, so we'll just do remove shared edges. So we just have this. And then I want to do a resample. So I'm going to do a resample and yeah, just make it big enough. Yeah, let's do 0.2. And what I can try is, let's do a polyframe. So we can just, adjust the normals. So we'll just do an N for tangent name. And we'll do like an up as well. Okay, and then let's just take a simple box and we will copy it onto this. So we'll just do, let's also do one thing. I'm going to do an add. We'll delete the points. Yeah, and then do a delete again. And we'll just delete everything on one side or the other. So do delete by expression at p.x. is less than 0. Yeah, keep it to points. Less than 0.01, and then do a mirror. Because the resample wasn't fully uniform, so now it will be uniform. Okay. And then I can just do a copy to points. Yeah, and let's make this really small. Yeah, there we go. See, so this is good. Let's try to adjust this. Yeah, let me just try something. Let's turn off. No, this is fine. Yeah, okay. So this is good. This is what we want in general. They won't be like 100% accurate, but it's good enough to work with. And then we can try to do a Boolean. Okay, so I'm just going to take this and let's move this to the side. Let's do a Boolean. So we'll do a Boolean subtract, and like this comes in here. We'll bring this down. This comes in there. Yeah, there we go. So it's not perfect, but it works well enough. Okay. And then I can just, bring that out. And so if you see it, so this is where it gets slow. Okay, like the Boolean is where it gets slow. So what you can do, so we have like a whole bunch of issues over here, but it works. Like this is too big a piece, so I think that's causing issues. But what we can do is, instead of taking so many, let's take a group by range, or let's also come after the add. We'll take another delete. I'm going to do a delete by range point. So we'll delete every alternate point. There we go. So we don't have so many of them. If you want, you can give it a color so that it will be white. See, there you go. This is just for show, but I think a better idea would be to finally paint something like this kind of detail on it, rather than trying to do a Boolean, because the Boolean takes a fair bit of time to calculate. Like if I change the frame now, you'll see like it takes a good about 3 or 4 seconds to calculate that. And we can also try to bring it in with the VDB. So if you want, we can bring in the VDB over here. And that might increase the time even more. Yeah, because the geometry count gets a lot heavier. But yeah, like without the VDB, it's pretty quick. Like what we want is, we could probably scale it down a little bit more. Like if we take this, the poly extrude, and bring it down a little bit. Yeah, no, wow, okay, that. Yeah, so let's make this about 0.7. No, 0.8. So this is just an example. Like even when I was doing this, it didn't turn out, spectacular. But yeah, it's not a bad way to do it. Okay, so this is one thing. Okay, like it helps you add a little bit of detail on it. Let's do one thing. I'm going to bypass this for now. Okay, because it does take a little bit of time to calculate. Okay, the second thing we want to do, which is actually a little more important, is what we want to do is we want to find, we want center points of each individual cell and then use those to generate holes. Okay, so the problem is that we got rid of the names, right? We got rid of the piece attribute and we built our own. So we're going to have to redo, or we're going to have to rebuild the piece attribute. Okay, so what we need to do is, luckily, since we created that, the point number attribute, the C attribute that we created, that is still storing, that data can be used to regenerate the piece attribute that we want. So what we're going to do is we're going to come back here, like to our original piece. And we're going to start from this point itself. So what we'll do is we're going to take a delete attribute, plug this in, and we're going to delete the name, and we're going to start from scratch. So we're going to take a partition again, and we'll do, let's call it C, backtick at C. And so what this should do is it will generate hopefully it will generate what we needed to generate. Okay, and then again take a name and get rid of this. Name is C star. And then we're going to take another for each. So we're going to take a for each named primitive, and hopefully if you've done everything right, see, we're back to the individual pieces. So if I just come in here and just to show you that it's all working, if we just take a divide and remove everything, we'll just do like remove shared edges, and if you come back, okay, see, so you have this, and then if we bring it all the way back to here, just to look at it, see, so we are back to this. So we have like each individual piece back again. Of course we don't want to do that, but just to show you. Okay, so now what we want is the divide is fine, we do need the divide. Okay, or actually you don't even need the, so the divide is fine, because what we want is we want this to be completely empty, so we can find like the center of this. So you'll get something called centroid, like extract centroid. And so if you bring that in, it will generate like a single point, and you can have it in two places. You can either have it at the center of mass or at the bounding box center. Okay, I think center of mass is better. So if you look at this now, what you've gotten is on a per piece basis, okay, you have one dot, which is good, which is basically what we want. What we can also do is, before we do the divide, I would like to do a poly extrude and like offset it to the same amount, so 0.12. So let's just do a poly extrude here. Actually we can do a copy paste here. So let's do this. Let's do right click, copy parameter, paste relative reference. Okay, and then we'll take this, and I'm going to turn off output side. So we just want like an offset. Yeah. So what will happen is you will get it to be, at this point, which is where we want it. So that's good. Now what we can do is we can take a simple sphere and we can copy it to this. Okay, we can do like copy to points. Yeah, these are too big. So polygon, and then lower the radius a lot. And then we do the same thing. So VDB from polygon, we'll do Control C, Control V. Yeah, and let's go slightly higher. And let's bring this down. And we can do a VDB combine. Yeah, so take a VDB combine, and then we can just drop the second one here. And we'll call it SDF difference. I think I might need to go higher, or let's make this slightly bigger. Yeah, there you go. So there aren't enough voxels. That's essentially the problem. But let's just convert it back and see what we're getting. See, so we might need, firstly, we also have to mirror this. So just take a mirror at this point. Yeah. And make it smaller. So come back to the VDB from polygon and make it 0.01 or 0.008. Yeah, I think this is good. So if we look at this, we should have, see, so what you get is like, these kind of holes everywhere. And so then we can try to bring back the Boolean as well. Now this will take a little bit of time to calculate, because the mesh gets very heavy, so the Boolean takes time to calculate. But there you go. So we have like a bit of Boolean on it. But as I said, like if this is important, because we need to generate like those connectors. But this, I think you can paint, when you're finalizing the whole thing, because it just, it takes too long to calculate. The mesh is too heavy. So yeah, not the best way to do it. Or what we can try to do is we can try to do the Boolean here and then sort of let it flow down from there. Okay, so what we can do is, this is an option. Okay, so we can try to, let's disconnect this. Let's get the convert back, which should be fairly quick. Okay, and let's just, we're going to drag everything down. And then we'll do a Boolean at this point. So we'll just take this and this and that. Yeah, so we have this, and then let's feed that into the VDB. So I don't know what we'll get. Yeah, it sort of rounds it off actually, which is not bad. Let's try 0.006. So you get like some amount of detail back. This should actually be more interesting. It'll be faster. Yeah, see. So what we should get should be a little bit faster to calculate. Yeah, there you go. See, this is a lot better looking than what we were getting before. Of course, the mesh is stupidly dense now, but the result is a lot better. So yeah, so you can do this. So do the Boolean first and then feed it through a VDB, because that gives it a slightly better look. We can try one more thing with the VDB, which is, let's get the ISO value to like minus 0.001. What that does is it shrinks the mesh. Let's try 0.1. Let's just see what it gives you. Yeah, so it sort of like shrinks the whole thing, makes it look a little bit tighter. Now this can cause problems, because if your meshes are too small, it can cause intersections, or pieces just might disappear altogether. So you have to be careful about this, about when you're going to use it, but it can give interesting results. And we can also use adaptivity and make it like 0.1. 0.1 is too high, but it might give you a slightly cleaner result, or actually like a less dense result. Let's make it 0.02. Yeah, and what you can do is you can get rid of the normals from here, and here you can turn on compute vertex normals, because what that does is, if you're getting like these odd issues here and there, it sort of takes care of that for you. Like if you're getting like random black patches, this compute normal works better. Or not. Let's turn that off. Yeah, okay. Don't use it. It's causing additional problems. But yeah, there you go. So it looks nice because it gives you these sort of, these random cuts everywhere. They're mostly uniform, but they look nice. So yeah, so keep this normal. And then we can check it with the final, this thing. Move this down and yeah, there we go. So we have this. Let's give it some color. So we can just give it some color. And we'll make it darker. What you can also do is, if you just want to give it some fancy color, we can use a curvature. So I can just take a measure and we can measure the curvature of this. We can come to primitives. We'll come to points and we'll measure curvature and keep this to principled. That is usually a little bit better, or you can try curvedness. Yeah, I think this is better. You have like 3-4 options, so you can pick which one works for you. I think curvedness is nice. Okay, and then we can just take a color. I'm going to make the attribute name smaller because curvature is too much to type and I am too lazy. So I'm just going to drop this in here, and you can say ramp from attribute and curve. Yeah, there you go. See, so that looks nice. If you want to know the values, like how much the range should be, if you select the measure SOP, you'll see the value over here. So the value is from 0.0 something to about 7.7. Or if you see the ramp range, it's like 0.0 whatever to 0.4. Okay, so what I can do is I can come to the color here and let's make this 0.4. Yeah, see, so you get something a little bit better. So it actually looks nice because it looks like worn out armor. That looks nice. So I can just, adjust that a little bit. Or if you want it slightly smoother, then after the measure, you can take a smooth and we can say smooth out curve and we can drop that in. And yeah, see, so sort of it smoothens out the whole thing. You can decide what you want. What we can also try is we can mix this with the existing color if you want to create like that random color, if you want the whole thing. But yeah, I think this looks nice. So let's keep it here. Yeah, I think we have a problem on this end, which is the faces are reversed. Let me just try. Let me just work this out. Yeah, if you're seeing them as blue, that means the faces are reversed. So let's just come here and we'll put in a reverse at this point. Yeah, there you go. See, that's better. And we can do the same thing here. So let's just take a color and make this darker as well. Yeah, I think this is good. So there we go. So if we change frames now, we should get to see something a little more interesting. Yeah, actually, like that's the point, right? So if you remove the Boolean, you'll see the whole thing actually go faster. Like if I get rid of the Boolean, and now if I change frames, this will actually calculate faster. See, and if you bring back the Boolean, that adds a lot of time. Simply because, the mesh is quite dense and it has to calculate a lot. So it actually becomes longer. Yeah, so let's go back to frame 1. Yeah, so there you go. So this is nice looking, you're getting like a nice bit of detail on the whole thing. Okay, so in the next lesson, we will take these, like the center points that we had calculated, and we will connect them to build like an exoskeleton on top of the armor. So we'll take a look at that in the next lesson.